Hello students, today we want to quickly look at a very important term in correlation and regression that helps us to understand the foundation of correlation and regression that we are treating today. Now before I explain bivariate data, let's quickly look at what is univariate data. Univariate data is what we have been used to, that is very common. Univariate data is when one variable is being observed relative to a particular thing. Such data are called univariate data. E.g., marks of students in a mathematics class. Now we are looking at the mathematics score or mathematics marks with respect to each student. Our variable here is the mathematics score or mathematics marks. Okay, that's our variable, and that's the only variable. We are looking at it with respect to a particular student. Now let's look at bivariate data. That is very important and very crucial in correlation and regression. What's a bivariate data? As you can see in this slide that appears now, data in which variables are observed simultaneously in relation to a particular thing. So this time around we are looking at two variables, call it x and y. We are looking at two variables with respect to a particular thing. And I have an example, e.g., scores of mathematics and economics for each student in a particular test. We could call scores of mathematics our variable x and say scores of economics our variable y. And we want to look at the two x and y with respect to a particular student, and that's a bivariate data. We are looking at the two variables simultaneously. When we look at variables simultaneously like this, then we call them bivariate data. Good. All right, we're going to look at scatter diagram and regression line. For this scatter diagram is what represents the bivariate data on the graph. Is a way or a diagram that represents this bivariate data on the graph, and the line that is drawn on that scatter diagram is what we call the regression line. But before we begin that, let's see what we have on this slide showing up. When two variables x and y are related, they are said to be correlated. So we have talked about the bivariate data now. So if we have two variables x and y, for us to know if they are related, we say they are correlated. If the two variables are related in any way, we say they are correlated, and that's how the term correlation came up. Okay, correlation coefficient, as you are seeing in that last part of this slide now, is a measure of degree of association between x and y. How are the two variables that we are talking about, how are they associated? How are they related? To what extent are they related? And that is what correlation coefficient is talking about. We are going to come across each of these terms as we go ahead. Now let's look at the scatter diagram, and that's the diagram that represents our bivariate data. Good. A scatter diagram is a graphic display of bivariate data. This shows clearly the relationship that exists between x and y. It shows us the relationship that exists between x and y. So scatter diagram helps us shows on the graph the two variables or our bivariate data, and also shows clearly their degrees of association. Good. Let's take an example one very fast and look at it to buttress our points. The quantitative and aptitude test of scores of 10 job seekers as shown the following table. Okay, now and that's the table you are seeing on the screen. We are given tables, quantitative test score. Let's call that our variable. Let's call that our variable x. Let's assume that variable is our x, and let's call this one our y variable. So we have 10 of x variables and we have 10 of y variables. Okay, let's see how we represent this on a scattered diagram. So obviously this on the screen we have a bivariate data. One is x and one is what I have called y. Okay, and we are going to plot each of them on the graph, and this is the graph that is representing a scattered diagram. Okay, representing x and y. We are going to put our y variable on y axis and we are going to put our x variable on x axis. Okay, and that's why it has been labeled. Look at it. My x axis is labeled aptitude test. You can see that. And my y axis is labeled, sorry, my x axis is labeled quantitative test score, and my y axis is labeled aptitude test score. So we fix each of the value on the graph. When x is 6, look at the first column. When x is 6, y is 5. Go and put it on your diagram, and that is this value. When x is 6, y is 5, and that is this value you have here. When x is 6, y is 5. When x is 8, y is 6. When x is 8, this is 8 and y is 6, and that's the value you have here. I will just show you few of them. When x is 4, y is 3. X is 4, y is 3, and that's the value you have here, and that's what you have there. Okay, when x is 7, y is 5. When x is 7, y is 5, and that is that one that we have there. Okay, so that's how we are going to plot all the points until we get to the 10th column. There are 10 columns there. Okay, good. So let's move ahead. So what you are seeing on the screen is a what? Scattered diagram representing our variables x and y. This is a scattered diagram, and this line that you have that is drawn, this straight line, is what we call the regression line. The regression line. How did we get that line? You draw the line in such a way that all the variables surround the line. All the variables are distributed around the line. It may not pick all of them, it can only pick one or two, but others will revolve around. So you pick the line of best fit. You draw the line of best fit. Okay, but all the same, in our next example, we are going to see a perfect way of determining that regression line in our next example. Good. So we have succeeded to learn how to plot a scattered diagram. Good. Let's look at our next slide. Example 2, obtain a regression line equation for the bivariate data. We are using the same bivariate data. We want to get a regression line equation. Since it's a line of equation, we are already used to equation of a straight line. Good. Now what we need to do first. This is the solution. Like I said before, I have this is my x variable and this is my y variable. That's the way I'm representing it. So I'm listing everything I have in this column. Sorry, in this row here. They are listed in the x column. Everything I have here, they are listed in the y column in order like that. Okay, so we list everything column wise. Okay, now we need to square the values of x, and we need to multiply or get a column for xy. If I square each of the x, I have 36. If I square 8, I have 64. If I square 4, I have 16, and so on and so forth. So this is s squared. Square each of the values of x, and for this column, multiply each of the values of x and y. Like now, 6 times 5, the first row there, give me 30. 8 times 6, the second row there, gives me 48. 4 times 3, the third row there, gives me 12. Okay, so and so on and so forth. So if I add all the values of my x, that's the summation x. That's what we have here. What's the summation? Add all the values of x, that gives me 59. Sum all the values of y, that gives me 45. Sum all the values of x squared, I have this, and sum all the values of xy, I have this. So this is very important. So with this, we are set to obtain our regression line equation. Okay, the regression line we obtain on that graph, we can get an equation that represents it, that gives us a perfect line. Okay, good. So let's see what we have in our next slide. Now, this is the equation of a straight line that we are going to be needing. We all know this equation of a straight line. Okay, y equals to ax plus b. Of course, we all know my a is the what? A will be my gradient, while b is the y-intercept. You remember equation of a straight line. Since a regression line is also a straight line, our equation will not change. Good. Now let's see, this is the formula. Our a is represented by the formula you are seeing on the screen. So you need to commit this formula to memory. This formula you are seeing on the screen right now is the formula to find the a, that is the gradient of that line, the gradient of that regression line. This is the formula. Okay, now let's see all the values of our x. Now, what's n? N shows us how many data do we have there. If you count the variables, the data one by one, there are 10 in numbers. We have 10 of x, we have 10 of y, so n is equal to 10. So my n value is equal to what? 10. That's why I have 10 in that particular place. That's why I have 10. Summation of x, y, we are bringing this from each of the columns. You know, we have gotten all the summations. My summation of x, just fix the values. Summation of y, and n again, this n, that's the 10 there. Okay, and summation of x squared, that's 417, and the summation of x squared, and that's this value. Just simplify, and this gives us the value of a that we require for that particular regression line equation. Okay, look at it. To obtain our b, we need this formula. So we have another formula that represents our b, and that formula is this we are seeing. This particular formula on the screen, where I have put asterisk now, represents the formula for our b in that equation, y equals to ax plus b. That's the formula to obtain our b. So a has a formula, the b has a formula, which is the y-intercept. Good. Let's forge ahead to get our to get our y bar. The formula is summation of y over n. That's the mean of the y's. Okay, if I sum my y, I have that value, and if I sum my x, I will have 5.9. Okay, remember summation of my y is 45 divided by 10, so I have 4.5. The value of my x by x here is 5.9 because my summation of x was 59, and if I divide that by 10, it gives me 5.9. So substituting, remember our a This is our a here, our a. We substitute in that equation, so this represents the value of my b. That's the value of my b. Okay, good. So I've obtained my a and I've obtained my b. So let's see what we have next. So my regression line equation becomes y equals to, remember my a is 0.6894, then x plus the value of my b will now be 0.433. Okay, 0.433. So this is what I'm seeing, you are seeing on the screen right now, is our regression line equation. Okay, so we've succeeded to obtain our regression line equation. Oh, thank you for listening to this video. Make sure you go through all the pages that we have in the portal for today. Thank you for paying attention.